back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're talking about outages at Google Cloud and OpenAI. We'll also keep you up to date with the latest global outage figures. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco Thousand Eyes. As always, we've included chapters in the episode description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. On June the 12th, many applications, including Spotify and Fitbit, began experiencing issues, and it turned out there was a common cause.
Yeah, if we take this back a little bit, on May the 29th, Google actually rolled out a new code implementation. This is intended to enhance the service controls functionality. It was actually going to introduce some additional quota policy checks. This code actually remained dormant during this initial rollout phase, and it required a specific policy modification before it be activated. So fast forward now to June the 12th, and then we had an event that actually triggered this dormant code. It was a policy change which was made to the regional spanner tables that this service control actually depends on. Now, the spanner is Google's globally distributed database systems, and it's actually engineered to replicate the data in real time across multiple data centers, sort of globally. And the reason I mention that is because that sort of tells us how it propagated so quickly. So this policy change inadvertently introduced some unintended blank fields into these spanner tables. Now, these fields were either empty or not properly initialized. So when the service controller attempted to execute the code with these new policies that were in place, it encountered an issue. So basically what it did, it actually said that it went to these locations and there was no data there or incorrect data there, and actually caused the sort of binaries to crash and the system to sort of restart themselves. So this fault effectively was identified in the distributed API management and control plane infrastructure, and it sort of integrates with the identity and access management functions. And now this is core to every API request in the processing pipeline. So this is essentially responsible for authorization, policy enforcement, and quota management. So this is when we had this problem. So if we're actually making a call from these systems to this back end, we make an API call and it has to sort of go through and verify. Obviously, it can authenticate who you are, but then it didn't have any information of what quota. And what that means is what you're allowed to do. So it knew who you were, but not what you could do at that time. And then it went to this sort of crash mode.
What impact did this have on services relying on Google Cloud?
So we saw this sort of manifest itself in different ways across the applications. Google identified what they say they saw an increase in 503 errors, so this sort of service unavailable. We saw a series of different errors depending on where we hit the authorization chain coming through. So some applications were sort of failing early on, or they were timing out because we couldn't reach the back-end systems. And some we were going through this almost cycling process where we're seeing a series of errors. So we're seeing sort of 401s where unauthorized. We're then seeing sort of 503s or 500s where it was systems unavailable. And this gave us clues to where it was. Now, I said the reason it actually sort of propagated so fast was because this change went to the database, and the database is set to replicate really quickly. This then also had an effect of when we actually needed to roll it back. So it was identified what the problem was. Google identified this, but then to sort of roll it back, they sort of had to reset systems and clear this down to the point where we had one location at the end, which was in the US, which was sort of still impacted. So we saw this tail-off effect. Now, what this then sort of did in terms of manifesting itself was we almost had this light dimming type of effect where we talked about in the past where we have a lights on, lights off situation. If we see some sort of network failure, things go down. A backhoe digs up a cable, it goes off. You have this complete failure at that moment in time, or a system crashes from there. But because of this system propagating around the place, we sort of saw this. It wasn't a gradual decline. It went quite quick as the policy went out. But there would have been some systems which potentially could have got up or not impacted because they had sort of stuff still in the cache and they weren't making calls to that back-end system.
Cloudflare also experienced an outage on June the 12th. Was this connected to the Google Cloud outage?
So yeah, they were actually connected. It actually primarily impacted some services, including sort of Workers KV. Now, Workers KV relies on Google's underlying storage infrastructure. And it's actually used by Cloudflare to store crucial information such as user configurations, routing information, testing setups, and authentication tokens. Now, because we actually had this same issue where you couldn't actually sort of get to that system, this sort of impacted it itself. So although it knew who these connections were being made to, it actually then couldn't sort of authorize it. So as a result, we sort of saw these back-end storage became inaccessible to the Workers KV sort of stuff, and then had a cascading impact because of the information you needed to get from that system. Because Cloudflare couldn't gain access to this backend storage system, it couldn't get hold of this other data, which then had this sort of roll-on effect itself. There may be systems that are actually using Workers KV there that were Cloudflare customers that weren't aware that they had this dependency within Google. So these dependency chains sort of run deep and far. Even to the point where we're looking at some of the other outages or systems there, where it may have been something within a page like some sort of analytics tracker that was on there that was actually functioning and needed to authorize back from an API perspective within the Google, that the actual service provider wasn't aware that was on there, or you as a service wasn't aware. So you had these hidden dependencies, but also the dependency chain was very long. This depended on this, depended on this. And the key point to that is these independent services are not even really independent. Even if you sort of think you're cloud agnostic across there, that there may well be some sort of underlying commonality across the systems when something like this happens, impacts you.
Is that because there's only a handful of major hyperscalers? So at some point, you're going to end up back with one of those big companies?
Yeah, to a degree. I mean, there's lots of shared services, and there's also they're sharing services between themselves as well. And people go through this access, and even find this when you're looking at sort of how the hyperscalers are connected together. I'm going to split across two cloud providers. When I find out they're both using the same subsea cable system, because that is the only way to get between sort of A and B, or they're on a campus where there is only a couple of ways in and out. So I have this commonality across there. So it's a combination of the two. Yes, because of the three main people, but at some point, because of the way dependencies are, you're going to have some sort of overlap. The key to all of that is to understand your system. There's nothing essentially wrong with having these points or these aggregating points, but if you're aware they're there, then when something does go wrong, you quickly identify where it is. So you're not sort of suffering essentially for that long period. You can make a decision to implement some mitigation process or switch to another system or these types of things.
Do you have any tips for navigating these outages that stem from the third-party service providers you rely on, or the third-party providers they rely on?
It comes all about to sort of identifying where it is. We need to be able to understand our complete service delivery chain, what we're dependent on, and if possible, where you have these hidden dependencies. If you have a component within a page or something that's sort of plugged in there, I need to understand where it is. And then it really comes down to sort of understanding where that fault domain is occurring or where that degradation of system's occurring. Can you mitigate it yourself? Is there something you can do from your environment on the domain you control to make those changes? Or is it something you either need to work around, either from a routing perspective, or do we change services, these types of stuff? And obviously then take all that stuff into play, because if there's something that comes in that you can identify that you can make a change when an issue on this occurs, you can either build and plan out for redundancy in the future, so you rule out that single point of failure in the future, or alternatively, what you actually do is build automated mitigation processes that take place. So if I do have this sort of commonality occurring there, what I might do is route around it. I'm going to re-advertise myself under a different prefix, so you can sort of take steps. But first point of all that is understanding the nature of the fault or nature of the degradation and understanding where that fault domain is.
OpenAI also experienced an outage recently that impacted its API and ChatGPT services. What do we see there, Mike?
So this was an outage that began on June the 10th around 6:36 a.m. UTC, and it was due to a routine operating system update on GPU servers. The ChatGPT error rate sort of peaked to around 35% at their worst period. We had these impacts to the backend servers themselves. We saw delayed performance, we saw increasing timeouts, and some degree of loss where these systems were actually sort of not communicating. A key point of this was we could actually, again, get to all these GPUs. You could actually reach OpenAI or ChatGPT servers themselves. It was just when you're trying to execute that. So again, that sort of tells us there was something within the back-end system itself. According to OpenAI, this was the result of a scheduled system update that actually restarted some network management services. And it caused a conflict with the networking agents on the production nodes. And what happened then was the routes were removed from the affected nodes, and this caused a loss of network connectivity. So effectively, we had this reduction in the capacity of where we can actually get to. Then how this manifests itself, as I said, was this slowdown or this failure to actually make these service-to-service communication calls. And this is impacting that performance themselves. So this was sort of compounded across. If you think about the architecture that we're looking at from ChatGPT, we had these multiple mechas where we're making these calls, and each database and these VMs are sort of trying to do queries and come across there. So we're looking at this essential load scenario. One of the first things what people were looking at was saying, is this load related? But if we actually think about this concept, this entire system has sort of been designed from a load point of view. So it wasn't essentially something sort of changed from the outside. So therefore then had to be something in the back end. So in terms of the recovery process, what they did was they re-imaged the affected GPU nodes and they halted this background update mechanism. So then they could actually sort of recover the system. What they've done going forward is they've disabled the updates to the GPU VMs and they've updated the system to prevent these conflicts happening again.
What takeaways can ITOps teams draw from this OpenAI outage?
First thing we want to do, if we look at this from a general point of view, so I need to identify where that fault domain is and what conditions may have actually triggered this. So if I'm looking at this environment and understanding how your application and what it's designed for. So something like ChatGPT is designed to take an extreme amount of load. It's highly unlikely this is going to be sort of load related. So that's the first thing we need to do. The second point is we could actually get to these services. So therefore, we're actually not necessarily looking at a network problem. And there was no sort of significant loss. The way it's manifested itself was in some sort of performance degradation, essentially, or sort of timeout system itself. The next thing to actually then do is to try and understand has there any recent changes done? Has there any sort of deployments or infrastructure modifications that may have taken place with the environment? This might not always be known across organizations, which is therefore why it's necessary to understand your entire service delivery chain, including those dependencies and those deep dependencies themselves. Because what that then allows me to do is that you might not be aware that a change has been taken place, but it's actually to try and understand where that fault domain is. So you can say, okay, it is lying within this point here. It's when we're making these API calls. And therefore, then you can have that information to contact that particular organization or that part of your organization and to have them instigate that change or tell you, oh, yeah, we've made a change to that system. Obviously, if you can then start to automate that process, then you can actually have these systems where I roll back quickly. This was a fairly lengthy duration, right? So this went on for a long time. And as I said, it was actually a degradation of performance as opposed to a complete sort of failure. But it, in some cases, amounts to the same thing. People couldn't actually use the service. So sort of understand where this system is, understand, you said, where this break point is, but then also seeing what you can do to actually fix that. We know this is going on for a long time, or we can see where it is. It's lying that system there. What can we do to mitigate or work around it? It may be, in the case of this, I want to use some other service itself, or it might be, as I said, that we can actually sort of change our appearance, either by changing our routing prefix or going to a different point. So, maybe we'll access via VPN because we have some sort of network problem where we're actually getting into that service. I'm going to appear as on the other side of the world. So take those types of approaches to it.
Thanks for the deep dive into those outages, Mike. Now let's turn to the overall outage trends. And what have we seen in recent weeks?
So after peaking in mid-May, the global outages then started to decline over the subsequent weeks. So from May the 19th to 25th, ThousandEyes observed 383 global outages, which represented a 29% decrease from the previous week's high of 536. This downward trend continued to the following week, which was May 26th to June the 1st, when the outages dropped further to 241, which was a 37% decline, so reasonably large there. Now, this downward trend reversed during the week of June the 2nd to June the 8th, where global outages increased from 304, which was a 26% rise from the previous week. The upper momentum continued into June the 9th to the 15th, with the outages climbed to 376, which was a 24% increase, and bringing levels close to those observed in late May. So the United States followed a similar overall pattern during the May 19th to June 15th timeframe. So from May 19th to 25th, US outages remained relatively stable around 147, sort of showing minimal change from the previous week's 149. Now, during the week of May the 26th to June the 1st, the US outages decreased significantly to 84. This was a 43% drop. So while global outages started to rise the week of June 2nd to the 8th, the US outages continued declining slightly to 77, which was an 8% decrease. During the week of June the 9th to the 15th, the US outages again started to mirror the upward trend seen globally, with outages increasing to 135, which was a 75% increase. Over the 4 weeks from May 19th to June the 15th, the United States displayed varying levels of representation in the global network outages. So during the week of May 19th to 25th, the US accounted for approximately 38% of all network outages. This proportion decreased to 35% from May 26th to June the 1st and dropped further to 25% during the week of June the 2nd to the 8th, but then increased to 36% from June the 9th to the 15th. This trend reflects a pattern observed since April the 7th to 20th period, where the US-centric outages represented less than 40% of all record outages, but goes against the trend we've seen coming into the year where we saw everything was at least 40% and greater.
Looking at the recent month-over-month trends for US and global outages, we're seeing a departure from what we typically observe at this time of year. Can you tell us more about that, Mike?
Yeah, in the US, normally in the spring, we'd see an increase in outages. However, for the past 2 years, we observed a notable deviation in this trend. So in 2024, from April to May, the US outages declined slightly from 299 to 287, which is a 4% decrease. And in 2025, the United States experienced a decline in outages, which dropped from 531 in April to 516 in May. Now, this is a 3% decrease, which is in contrast to 2023, where we showed the expected seasonal increase from 451 to 597, which was a 32% increase. So this decline in the US outages over the past years is in contrast to the seasonal increase observed in 2023, but it may point to a reduced maintenance activity that sort of altered the traditional spring outage patterns that we've seen. And globally, we're also seeing different month-over-month trends than usual. So global network outages experienced growth from April to May 2025, increasing 2%, rising from 1804 to 1843. This pattern stands in sharp contrast to the historical seasonal trends observed in previous years. So in 2024, the April to May increase was more significant, rising from 687 to 822. Now, this is like a 20% increase. While in 2023, we saw an even more dramatic seasonal surge, rising from 1,024 to 1,304 incidents. Now, this was a 27% increase. Now, the relatively muted 2% growth in 2025 suggests either improved global network stability or more effective seasonal planning compared to the double-digit increases witnessed in prior years.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this ensure you're in the know when a new episode's published, it also helps us to shape the show for you. You can follow us on LinkedIn or X @1000eyes, or send questions or feedback to internetreport@1000eyes.com. Until next time, goodbye.